This is that whole thing of farming, and it started, probably the first time that the plow hit the land is, all of a sudden we start getting weeds, and why? Is it just to give us something to do, or is it actually having a function? So the title slide here, this is from Western Australia, in one of their paddocks, their grazing paddocks that they went dormant, and this is one of their weeds that a lot of the producers they always fight with, and it's called dock. And imagine that it's the same dock that we have here. And so once again, you look at what it's doing to the soil, look at the type of the soil. Maybe it's growing, it's doing something instead of just making us mad. So the first definition that we should get into is what is a weed? And simply put, a weed is just a plant growing where it's not wanted. In agriculture, the these weed seeds that we have, traditionally, for the early successional plants, they produce a lot of seeds. So things like green foxtail, red root pigweed, lamb's quarters, lots of seeds. And that is due to the nature of the successional placement of these plants. So these early successional plants usually produce a lot of seed. The other type of weed we have that we are usually concerned about are these deep-rooted weeds, which then relates back to that we have a compaction and hence a calcium flux issue in our soils. So that is the two of the main groups that we deal with, and so we're going to dive into it and just once again try and understand why these things are growing, what triggers them. So these weeds, where the role of the weeds are, is it's nature's response to the soil conditions that we have. So these weeds that we call weeds, and in a lot of cases are these early successional plants, they're aiming at fixing or changing the soil conditions. So in this picture, you look at it, we're dealing with low diversity, low growth, not really productive soil. So what are those weeds growing? What are they trying to do? So in some cases, in this case, it's nothing predominantly by grass. So these weeds, maybe they're looking at increasing the plant diversity. Maybe there's some salinity there, and so there's some weeds that are very tolerant to growing in saline spots. Is it a compaction issue? Is there's some nutrient imbalances, and the imbalances being twofold, whether not enough like phosphate, or is there too much sulfur or too much nitrogen, or is there just bare ground? Because nature despises bare ground. Hence, when we do black summer fallow, we get a lot of weeds because nature is trying to fix that problem that we are then managing for. So basically, when we look at what these plants, the role of them in ecology is they have some ecological advantage over the crops that or the plants we are trying to grow. And it's always is ironic the right word, that these weeds that are growing, they don't need any special treatment. We don't need to seed them. We don't need to manage them at all to get them to grow. But yet our cash crops we're trying to grow and trying to keep them alive. So that's a little bit of the irony in a lot of these cases. So that's why it's so important to read our weeds. It's telling us what plants we should be growing, so that when we have looking for these, why certain plants are growing and the ecological advantage they have, once again, is salinity tolerance. So you look at kochia, foxtail barley. They have a tolerance to salinity, which most of our cash crops we don't, especially the ones traditionally we grow. They have the ability to grow in anaerobic conditions. So this is basically your thistles and dandelions. They have different root exudates, and this is where that plant diversity comes in. And that different root exudate is really important for nutrient cycling and nutrient availability. Is it the different climate tolerance? So is it being able to tolerate warmer conditions, cooler conditions, wetter, drier? What conditions are triggering these weeds to grow? the tolerance to high soil nitrates. So in the picture, you see the red root pigweed and lamb's quarters. That's your first indication that you have excess soil nitrates in your soil. And soil nitrates in the soil are a toxin to the system. Or do they have this ability to extract nutrients at low availability in the soil? And this is going to relate back somewhat to the different root exudates, but we're going to get a little bit deeper into rhizophagy in future slides. So one of the books that I recommended farmers to get for the last probably 8 years, I need to run into J.L. McCammon and see if I can get a commission on book sales. This is a great book. This way, it gives you an indication of why some of these weeds are growing. What is some of their ecological advantage? So back in the day when I first got it and we're distributing it around, it was about $20 US. Acres USA is where you can get this book. Sometimes you can get it through Amazon, but just so you know, there's sticker shock now. Now this book, last time I checked, was $66 US. But $66 in the big picture to understand what these weeds are telling us. It acts as a little bit of a translation device for us. So one of the things that it does is it goes through. So on the top, it has it has a little bit of blurb in the first 50 pages or whatever it is about background on some of the ecology, some of the agronomics. But in the back, what it has is a chart like this, where it has a common name, scientific name, so that this way we can do some translation, and then the nutrients across the top, and then some soil conditions on page 2. So if we are going in, and I highlighted field bindweed because it's not something that we're used to seeing in the Canadian prairies, but as soon as you go to North Dakota, all of a sudden it shows up quite frequently. So this way we can go through and we can see field bindweed. Okay, so what conditions does it tolerate? So the calcium very low, phosphate very low, potassium very high, magnesium very high, and then you go across to humus is low. The drainage is low. The residue, soil residue is low, but you can also see in here that the porosity, bacterial dominated, how moist that soil is, the salinity, how hard is that soil, drainage, sand. So it goes through these different scenarios. So this way, when we look at this and it shows that we have low calcium, one of the ways to get rid of it is take away those, to flip those ratings. So if we're very low calcium, let's try and make it medium or high calcium availability. And it isn't from the soil test per se, it is availability. It's our fluxes. So when you go through this book, and you'll see calcium in just about every one of the columns being low or very low. Once again, we're dealing with an early successional plants, which usually means we have soils that have reverted back to early developmental stages. When we have that means we have soil structure problems. We have low fungal populations. We have low plant diversity, which all translate back to slowing down our calcium and our phosphate cycles. Once we get the diversity, once we get the fungi going, especially the mycorrhizae, we get the plant diversity, we get the living root, kind of like the 5 soil health principles. Now we can get these nutrient cycling, and these weeds will magically disappear. As stupid as that sounds, when we take away the ecological advantage of the field bindweed. So we put in that calcium, we increase the available phosphate. Boom, it lost its ecological advantage, it disappears. So going back to this soil and plant succession, because they go hand in hand. So that as our soils start their succession process, different plants start showing up, or on the flip side, different plants start disappearing. So we go from early succession to a higher succession to mid succession. Then we start seeing rose bushes and shrubs. Then we start seeing trees and it's going to be, that's going to fluctuate back and forth. Once again, get a little deeper into it later with the climatic and management practice that we do. But as a quick rule of thumb, certain plants prefer to grow under certain soil and climatic conditions. If we have the wrong soil conditions, we get poor growth. Whether, and especially when we start talking about the soil succession, basically, we have issues where, it's too bacterial dominated. So if we're trying to grow something like Sicer milkvetch or some native species, it's too bacterial dominated, it's not going to do well. Whereas we start growing mustard and canola in something that is very fungal dominated, it's not going to do well because it wants to be more bacterial. So just by changing this microbial population composition in our soils will lead to success. On the flip side, we need to know what crops we can grow to move it forward or move it backwards. So once again, picture, you can see my land is on the right, the road allowance is the grassy sod, and then the neighbor is out with tillage. So on my side, I'm promoting more fungi. The green plants are still balancing some bacteria. The sod, it's not getting any disturbance, so the bacteria populations start dropping off, but the fungal populations are going through the roof. And the guy over there that's worked down his canola stubble, well, canola highly bacterial, do some tillage, well, that's going to add to more bacterial, it's going to damage more fungi. So I can tell you the plants that are wanting to grow in each one of those three locations. So I've been using this chart for quite a few years. This Sustainable Growth Texas, in my mind, visually did a bang-on job of it. So that when we look at this soil and plant succession, when we have, when we get up into flim-flam and we're dealing with Precambium shield, we're dealing with this 100% bacteria. And as we start moving down, we're getting, where we start getting some soil being developed. Then, we start out with 100% bacteria. We get some lichens starting to grow on it, and then we start getting some soil starting to form. And where we are right now in most agricultural lands is we're in this fungal bacteria around that 0.1. And this is where weeds, they like to grow, early successional plants. Johnson grass, of course, don't have too much of that, but this is where the crackgrass comes in. We're dealing with high nitrates in our soils, and we're dealing with lack of oxygen, which then is by definition compaction. When we have compaction, when we have weeds, what kind of plants are we talking about? We're talking about wild oats, we're talking about red root pigweed, cleavers, thistles, dandelions. Those are all growing in this 0.1 to 0.3 fungal to bacteria ratio. And this fungal to bacteria ratio, it is pound per pound or kilo per kilo per acre per hectare, whatever size we're measuring. But it's just a quick ratio of weight of active in the soil. As we go through and we start increasing the amount of fungi in our soil, you can see that we have different plants that are being triggered to grow. As we move up, this is where, we start getting into the mid grasses, clovers, vegetables, late successional grasses. When we get to 1-to-1, when we get into the row crops, native plants, then when we get beyond that, then we start talking about our shrubs, vines, native species like that. Then we start getting into the trees, and then we get into pines. And so when we're going through this, this is the natural progression. And so when we start looking at areas, north of the 16 highway, traditionally in the past, prior to Europeans coming in, creating railroads and highways and doing tillage, we were prone to wildfires. So when we start getting north of 16, that still used to be prairie because we had fires coming through. Because as we go through and we watch this, we don't do any disturbance, we will progress, given there's no constraints from climate, to want to go to, up this snakes and ladder thing, this path. So as we go through, this is what we want to do. As we have a disturbance, it moves downwards. So this is where we hit a ladder and we start moving backwards. So as we look at something like seeding down a pasture or a hay crop that we're going to be using for, say, 10 years, what'll happen is most of us are farming in that 0.1 to 0.3, so we have lots of weeds. We'll seed down a diverse pasture or hay crop. That first year, we're going to use a nurse crop with it because we're going to harvest all those weeds off of that and get rid of them. And we get to see what every weed that is wanting to grow on the farm growing in that year. So we're going to bale it off. We're not going to do any other management to it. In year two, the forage is established really good. They come up early in the spring. We may see patches of weeds growing, but not very many, way less than year one, year establishment. Year three, we don't see any weeds. And so that'll continue until one time. And once again, if we're growing sisal or milk vetch, it may be year 4 or year 5 where it starts showing up. And that's an indication that we're at about a 0.6 fungal to bacteria ratio. If we're growing some native species like western wheatgrass, switchgrass, big blue stem, they may not show up for 5 or 6 years. So they may show up when that fungal bacteria ratio is close to 1 to 1. But as this field progresses, hay production starts dropping off. That's the plan. Then we turn it into a pasture. And when it's in pasture, or if it's been pastured all along, if we've been overgrazing and underresting it, then we start seeing rosebush, buckbrush, silver willow. We start seeing some of those shrubs, choke cherries, things like that starting to show up. That's an indication we're at a fungal to bacteria ratio in that 2 to 1 to 5 to 1 range. So what we need to do, and it isn't because we have way too much fungi, is because of our plants, as they mature, they produce less and less root exudate, which then feeds our bacteria, which then drives our ratio up of our fungal bacteria ratio. So what we need to do is get more root exudates or sugars back into our soil to get our bacteria up and going, so we can then lower that fungal to bacteria ratio to get nutrient cycling going to then get productivity. If we go in and we decide we're going to rip it up, so we go in, we disc it, and of course, if you disc it once, it's going to be sod bound, so you're going to have to disc it second time. You're going to have to go, it's going to be rough, so you're going to go in with a cultivator, cultivate it a couple of times. You're going to do all this tillage. So what's happening every time we do tillage, we're decreasing our fungal to bacteria ratio. So we may be at a 1 to 1 when we start disking it. So we disc it the first time, we may go down to a 0.8. Disc it the second time, we're at a 0.6. We do some tillage, we're at 0.5. And the year after breaking hay or pasture, seeding oats, you can grow good clean oats after you harvest or after you're breaking up this pasture. So seed oats into that, no wild oats. So you harvest the oats, you go out and you do some tillage, you till in the spring, and you seed oats again. And until we as long as we're over that 0.3 fungal to bacteria ratio, you're going to stay where the wild oats will not be there. So they may be in the low spots, they may be in water runs, they may be areas where they get more disturbance or less fungi in our soil, and that's where the wild oats will show up. Once we drop below that 0.3, we're back into growing wild oats. So we were managing for those weeds. So when we have these pastures and hay perennials that we have in, what we want to do is try to terminate these perennial stands that have a really good fungal population. We want to be able to terminate them and manage them so we maintain that fungal population as long as we can. Anything we can boost it, that's what we need to do. When we go in and we overwork it, that's an issue. Not having something growing in the fall as a green vegetative plant, that's another huge issue. So these are some of the strategies we want to do if we want to be managing our land so we're not growing weeds. We need to manage our fungal to bacteria ratio. Now, when we start talking about dry land, and so when we're talking about down that Lethbridge area, I see Scott on, so we're going to talk about what happens there, because our climate is going to be limiting how far we can go. Now, you don't see a lot of trees or a lot of pine trees, spruce trees growing out in the prairie in around Raymond. It's because our our climate stops our progression of our fungal to bacteria ratio. So we will get into that 2-to-1 or 3-to-1 fungal to bacteria ratio, but we don't have enough rain, that especially fall rain, to get that fungal population growing any further. So it is interesting how the climate will limit what can be grown. So can we grow, like if we seeded some pines and spruce in the deserty parts of Western Canada, we can. They're not going to be happy, but there's some tricks to get them established. So we're annual weeds. So wild oats, green foxtail, pigweed, lamb's quarters, kochia, Russian thistle, bindweed, wild buckwheat, purslane, stinkweed, mustard, flaxweed, tansy, mustard, chickweed, shepherd's purse, bedstraw. What else do you want to throw into that one? Basically everything else that we grow and regard as weeds. One of the things that happens is it's triggered because of excess soil nitrates in our soil. And that is a result of bacterial dominated soils. So that when we have when we go out and we do tillage, we want to go out and we do want to do early tillage in the spring because we want to stimulate weed growth. We need to know why. So if we go out and we do a pre-seed tillage to wake up the soil, what that's doing is it's aerating the soil, it is warming up the soil, and it's stimulating bacteria. The bacteria wake up, and so they've been basically sleeping all winter. They're going to be hungry, so they're going to start, wanting to eat. And what do they eat? Because they are biological systems like ourselves. They need to eat carbon-based nutrition, so that when they wake up, there's nothing growing. They're going to start eating our soil organic matter. That soil organic matter has the C/N ratios too rich for them in most cases, so they'll start pooping out a bunch of nitrogen. If there's no plant to use it, that nitrogen gets broken down to nitrates. Once our nitrates get to a certain level, that's going to trigger these early successional plants to grow. So if we have a nice green mat in the fall of vegetative plants, and we direct seed into that, those microbes have something to eat. They have that green, it'll be brown plant material in the spring. So the tight carbon to nitrogen ratio, so they're going to get lots of carbon, and they're going to leave the soil organic matter alone. You're going to have a growing plant there if you direct seed into it super early, and super early is all relative. But get your cash crops established early so that they can start using that nitrogen that the soil microbes are then producing. So we're not going to produce that free nitrate in the soil, which is then going to trigger our weeds. So it's really important to managing our carbon in our soil. When we don't have that carbon going in the soil, we're going to get excess nitrates, we're going to have compaction, we're going to have all these problems. So we need to really be pumping this carbon into that soil. The other thing, when we start talking about these the secondary advantages of these plants, and so this is where the things like salinity, so the kochia, Russian thistle, foxtail barley, they'll have their advantage. And how do we deal with that? Well, once again, to deal with salinity, first of all, we have to stop evaporation. So that means we need to have good soil armor on. We need to have living roots to use the water deeper in the soil profile. We need to have our calcium cycles working properly. It's once again, once we understand these systems and how we can increase and keep our calcium flowing properly, our carbon cycling through the soil, then we're going to start winning. So the perennial weeds, once again, it's an indication of compaction, anaerobic conditions, goes back to low calcium fluxes in the soil. And it's not just because I did a soil test and it shows that I have 9,000 pounds of calcium in the soil. That's nice, but one of the things I look at is your base saturation in the soil. So you want to be in that 70% base saturation. You need to have that living root. You need to get the mycorrhizae going, and once again, we need to get the carbon in the ground and keep that carbon continuously flowing as much as we can to start building this humus in the soil. We build a humus that gives a soil structure, and it's really tough to compact that. Once again, you get into drought. because we have 2-to-1 swelling clays in North America. So that means that, when we add water to them, they swell, and when it dries out, they start contracting, and you can see in the picture where you can start seeing some of the cracks. So as that we add water to it, it swells, it increases the base plates on their clay particles. So then we get more calcium available to the plants. When it dries, it starts shrinking, and they start, making a brick wall. Plant roots can't get into there. So then our calcium flux starts to drop. Woody perennials, once again, when we start looking at, decreasing our bacteria in the soil and maintaining and building our fungi, then we start getting our woody forbs starting to show up. And the woody forbs, what they have as the advantage is they're able to extract nutrients from the soil by using the fungi populations in our soils. So with the grass, the plants that we want to grow, they need that bacteria. Bacteria cycle nutrients extremely quickly. When you start talking about fungi, they're slower growing, they're slower metabolizing, and so they are, they don't spin those nutrients as quickly as what bacteria can. So our cash crops, they suffer on it, whereas these forbs, these woody forbs, that's ecological advantage of them. So strategies for battling these nasty weeds that we have. So our annual weeds, we want to build our fungal bacteria ratios, and we want to build diversity in our microbial populations. And this is where, the soil health principles kick in. And this is keeping that vegetative plant growing in the soil for as many days as possible, minimizing the soil disturbance, reducing synthetic reliance. And when I'm talking synthetics, this is also in organic, because there are some synthetic, not synthetic chemically necessarily, but there are some things that we're adding to the soil that are messing things up. Increasing functional plant families that we're using in our rotation and in our cover crops, and properly incorporating livestock where possible. Those are the important things that we need to be doing. And when we start doing that, like I said, these annual weeds magically disappear once we start reading them and using the species that are replacing the ecological service of that weed. We need to minimize that free soil nitrate in the soil. So when I get a soil test from someone, this is one of the things I'm looking at, is I'm looking the free nitrate in that soil test. If it's high, I know their system's broken. When you see in this oat picture with the Italian ryegrass growing underneath it, if you do a soil test, at this time, your soil test is going to show you have very little left in the soil. When in the spring, when that Italian ryegrass dies and it releases, all of a sudden you can see a huge jump in the nutrient availability in that soil. So this is that catch and release. There's a Hutterite colony over in Bigger that I did some work with, and he brought me 3 soil samples, and he said, "What's going on here?" So I said, "What'd you do?" Well, I said, "Well, we silaged all 3 quarters." So the 2 quarters were coming in at 30 pounds of nitrogen in the soil, and the third one was at 88 pounds. So I said, "Okay, so what did you silage?" He said, "Well, on these 2, the first 2 we silaged barley. The third one was a cover crop that was green in the fall." And I said, "Well, that cover crop that you had growing there made you an extra 50 pounds of nitrogen." And so this is the fallacy of, needing to keep it black to keep your nutrients and keep your water. There's so much research out there now showing that cover crops, number one, are going to conserve more water for you. It's going to infiltrate more water for you, and it's going to cycle and make more nutrients available for you. Now it's managing it so it doesn't get, in the spring, using all the soil moisture so you can't get a crop out of it. But this vegetative stage, keeping things low, keep it growing, using mowers and swathers, using livestock, these are the ways that we can keep these crops green, growing in the fall, and making money. Because once again, if you go in and till it, that's going to cost you, use whatever numbers you want, but about $25 an acre to tillage. If you get someone with cows, or you have your own cows, and you get paid $30 an acre for $25 an acre for grazing it, well, that's a $50 swing. So that's $50 in your pocket. So once again, these annual cover crops, we want to play this catch and release with nutrients. If we want to keep the nitrogen in our soils away from that nitrate phase. We want to have that vegetative plant in that understory because it's going to absorb. And if you have Italian ryegrass, which grows 3 or 4 inches tall, and it keeps absorbing because nitrate's passively taken up by the plant. So if it is absorbing all this nitrate and it converts it over to amino acids, proteins, and other nitrogen-rich compounds, once that protein of that Italian ryegrass gets to 18 or 20%, it's going to say, why do I have so much nitrogen? It starts releasing the more complex nitrogen forms as it keeps absorbing this nitrate. And when we do that, it's really energy expensive for the plant to convert nitrate over to amino acids and proteins. It takes 4 to 5 steps. So it's easier and better for Italian ryegrass to be doing that than your cash crop. That cash crop can then take up that amino acid and protein directly and put it into amino acids and proteins. And it costs 0 energy for that cash crop. So these are the things that we want to be doing. And so the way we can get around some of this is, number one, we can, we to put down that big green manure crop and then have all this nitrogen sitting there. It's great for fast growing crops. But what happens, if the crop uses it because it's converted to nitrate and you get all this vegetative growth and you get lodging? So it's almost better to go in and look at options of foliar applying nitrogen. And so, we're not just talking about adding, chemical in, but we can use things like emulsified fish. There's a lot of organic opportunities to seed or to spray on some of these water soluble amino acids. And then the other option is using these legumes with your cash crops to then help feed that cash crop with these annual clovers, fixing nitrogen as your cash crop needs it. So the perennials, when you're talking about perennials, when we're fighting these weeds, one of the things we can be doing is using, deep-rooted cover crops to help battle these perennial weeds. So, using the radishes, chicories, lupins, sweet clover, they're all great for getting the roots down. And the other thing is not over-applying nitrogen in our system, because Terry McCosker has the numbers of 1 extra pound excess nitrogen in our system destroys 100 pounds of humus. And that humus takes 100 years to produce, and very stable, very important in our soils. And in our systems, when we are using these clover plowdowns and not matching it with forbs and grasses, then our carbon nitrogen ratio in our soil start getting out of line. Once again, microbes in the soil are looking for carbon, and if we're not giving it as a root exudate, what's going to happen is it's going to start eating our organic matter and our humus in the soil. So these are some things we need to be considering on our long-term management. We need to improve our calcium cycling so we can flocculate that soil, and we don't get these issues with compaction. And this is where the mycorrhizae fungi slide. They thrive in it. And so in the picture, what I have is in a field that I was out rooting around, pardon the pun, but there is a thistle plant and a chicory plant growing side by side. And when you look at what a thistle does, it can go through compaction, it gives aeration, it accumulates calcium and phosphate. Well, chicory does the same thing. And so the chicory root is on the right, thistle's on the left. And so when we have the same ecological function, the thistle then disappears, because we're supplying the same ecological function with a plant that we can manage more easily. So that, these are some of the things we can be doing. So rhizophagy. A year ago, I spent a day with Dr. James White, and a really interesting guy from the standpoint of his research. So rhizophagy broken down is rhizo is root, phagy is eating. So he explains how the plants eat and obtain nutrients from the soil. And basically, the Reader's Digest, is the root tips are ingesting soil microbes. So those, as the root tip is pushing through the soil, the root cap kind of thins. The microbes are then pushed through the cell walls. The plant then strips off the cell walls of those microbes. They digest the cytoplasm of those microbes. They are then cycle the nuclei of those microbes around within the cell walls, and they replicate them. They produce more. When it gets to a certain point, then all of a sudden they spit all those nuclei back into the soil in front of the root tip. They then give it some root exudate and some stimuli to then reform the cell walls around those microbes so they can go back functioning like microbes in the soil. So they'll go through, they'll break down, the organic matter, they'll do their microbial things in the soil. And guess what? The root tip then pushes ahead and reabsorbs them, strips off the cell wall, increases the nuclei, eats the cytoplasm, then spits those nuclei back into the soil. This is the way that the research that he has, he's estimating about 85% of the nutrients are taken up that way. The only things that really get taken up through the cell wall, through the soil solution, are the water soluble stuff like the sulfate, the nitrates, the boron, things like that. So this really stresses the need for soil microbiology and lots of diversity. So assuming the soil and the stored soil nutrients are not eroded, leached, or volatilized away, we have all the nutrients in the soils that we'll ever need through, Dr. Ingham, she says but for average soils in Western North America, we have about 1,500 to 2,000 years worth of phosphate. When we do a soil test, it shows up we have 10 pounds. Whereas if we do a mineralogical test or a Sparks test, it'll show that we have, 3 to 6,000 pounds of phosphate. So how do we get that out? Soil biology. And so this is where, when I brought the Haggertys over this last summer, to explain their production system. So what they do is they don't use any synthetic fertilizers. All they use is some compost on the seed. They use a liquid compost extract in furrow, and then they do a foliar application of a compost extract. In that compost extract, they do put vermicast, humates, kelp, molasses, and I'm blanking. Okay, but it works. It absolutely works. We just need to get our soil biology, our diversity up and going. When we start talking about increasing our plant diversity, we need to work, when we start talking about intercropping, things like that, we need to have this, I always talk about my little triangles, that legume grass forb as triangles. We need to have those growing in, as, if not together, in a system where we can have representation. Because if we have these different root systems in, and as long as we're not going out and destroying the rooting zone with tillage, we have this thing called legacy effect. So that as we have, if we're growing these shoulder cover crops, the roots of the next cash crop is going to grow where the old roots were growing. This is going to then give this legacy effect, so that the plants that we're growing now will follow the old root channels of the plants that we grew in the past, and they'll have access to the old microbiomes of those other plants. Those are shared with our cash crop, and it'll use whatever microbes that it needs to boost their own soil microbiome and make their plants more functional. So ideally, grass, legume, forbs, you stick with those three, rotate them through, mix them in, and you'll start seeing huge differences in your soil aggregates, your water infiltration, and your pressure from non-desirable weeds. And it also builds that power of the mycorrhizate fungi. So some examples, some wild oats. What triggers germinate wild oats? And basically, it's excess free soil nitrates in the soil. Your fungal bacteria ratio is going to be under 0.3, low available calcium and phosphate in the soil, and it's trying to fix these issues. So, it's very mycorrhizal friendly. If you want to build mycorrhizae in your soil quickly in tough soils, wild oats do a great job of that. It creates a wide carbon nitrogen ratio residue. So, in that stem, they don't break down all that quickly. So this way it's going to create some armor, and it's soaking up all these free nitrates. And if these nitrates, if as long as you're not feeding it to animals, it's soaking it up. It's taking it away. So then our cash crop is going to be lower nitrate. And we'll talk a little bit if we have time at the end of implications of free or excess, just free nitrates in our plants. If we are talking about, down in the dry parts of the prairies, some of these drought tolerant weeds, they thrive in low organic matter soils. And it may be, and once again, if we have plants that are able to establish, because we just don't want to kill the plants and have nothing growing there, but if we're actually getting plants to establish that we want, and we have some of these drought tolerant weeds that are growing, we might be able to just put on some fulvic acid, spray that on, and kill them. The reason why I'm leaning that way is when we started playing around with humic acid and fulvic acid on our farm, my wife was playing around in her flower pots, and she saw some incredible results in her flowers. And so, okay, into the house, we're going to try it in the house plants. And she put some humic acid on some of the succulents, the cacti, and they were dead in 3 days. And so I got a hold of Dr. Muir and asked him, I said, what do you know about humic acid and cacti? And he said, not much. Why? So I explained what happened, and he said, oh, yeah, well, that makes sense, because where did cacti grow? In low organic matter, low humus. So if you give it humus or humic acid, it's going to say, oh, I don't belong here. And it's going to disappear. So weed removal does not make weed disappear. We've proven this over the last 150 years, or you go back even further into the past civilizations that were agricultural based. This tillage thing does not work. It absolutely does not work. Herbicides does not work. They're both broken systems for weed. And once again, we need to listen to see what those weeds are trying to tell us. These weeds keep coming back if the management is consistent. Guess what? If we change our management and we start doing the soil health principles and building our fungal in the soil, having those root exudates, tying up those the excess nitrates, building our calcium in the soil, now we've taken that ecological advantage away from those weeds. So we need to, look at, this nice black field. Is it nice and black? On this. So this is down at the Mannequin Farms, down at Bismarck. One of the experiments they wanted to do is seed corn, and then right before the corn came out of the ground, they seeded 12 pounds of alfalfa, which for most of Western Canada is way too heavy. But they wanted to see what would happen, and it turned out that year that was their best yielding corn. Once again, corn. Oh, you got to keep it clean because it does not tolerate any competition. When you go back to the three sisters, the beans, maize, and melons. This is, we don't have the broadleaf in here, but there's our legume, there's our grass. It works. So, and what did you see for weeds? Very little. So that, when we want to make these weeds disappear, we need to change the management so we're not managing to grow weeds. When we are talking about disease, our management now, we're managing for the disease. We need to change our management to take the ecological advantage away from our problems and give that advantage to our cash crop. We need to understand the triggers. Basically, it's that excess nitrates. It's low calcium flux, bare soil, compaction, salinity, lack of plant diversity, lack of something green. So when the knee-jerk reaction is this fall rye, cereal rye, especially in the States, where they're using it for weed control. And so, one of the things I'm asking producers is, okay, so why are you using it? And if someone says, I'm using it because it's winter hardy, it overwinters, I have salinity problems, okay, that makes sense. If it is because I like the weed control, we need to re-examine your management system, because why are those weeds coming back? Why is there excess nitrates? Why is there a lack of calcium? Why is there not more fungi in our soil? We need to look at that system, the system's approach. Using some other winter cereals like winter triticale or winter wheat, going to Festiolium or perennial ryegrass, that gives you a lot more options of getting more species in there. This way, when we get more species growing, once again, we're adding that plant diversity. We're giving different root exudates. We're doing so many more positive things.